Hello and welcome to today's video, where I'll be using JoeSandbox, which is a powerful tool for dynamic malware analysis, and the spyware sample for the video today in question is a keylogger. Firstly, you need to upload your spyware sample, and after successfully uploading it, you can choose the system. I'll be choosing Windows 10. We want a live interaction. You can set the runtime if you have Cloud Pro, although I do not. So I'll just be leaving that. And then after agreeing to the terms and conditions, we can begin the analysis. Once JoeSandbox has finished the analysis, we can see a few different pieces of information. It has classed the executable as malicious. It's given it the tags of Trojan and exploiter, and has also defined it as a PowerShell keylogger. If we open up the full report, there are a few visual and graphical pieces of information that are key to note. If we open up the image here, we can see a storyline of the executing of the keylogger within JoeSandbox virtual environment, where the PowerShell keylogger begins its actions. JoeSandbox has given it a score of 60 with 100% confidence. We can see some basic signatures here, which we'll analyze further, and then a classification tree, which we can see this sample has strong characteristics of an invader, an exploiter, some spyware characteristics, but they sit within the suspicious zone. And then within the malicious ring, we can see that it also has identified it as a Trojan/bot. The process tree is extremely helpful in us understanding how this keylogger performs. It firstly runs a PowerShell script as with the execution policy as unrestricted, which gives it full permissions. We can see it then runs an executable called conhost.exe in the command line, and then another executable, CSC, which is usually C# compiler, is also run, and this is stored in the local temporary folder with this command line script stored. This executable, cvtres.exe, is commonly associated with the Visual C++ development environment. Any potential for misuse involve this executable being mimicked or exploited by malware. If it is running from an unusual location, such as a temp file, it could be worth investigating further. The service host is a crucial system process in Windows that acts as a generic host process for running services. Its normal location is found within the C Windows System32 directory, which we can see is here, and then there is a cleanup at the end. JoeSandbox Yarrow rules detected that this sample is a PowerShell keylogger, and it was also able to compare these against some memory dump to come to the same conclusion. First Sigma rule shows that the PowerShell script when run is specified as execution policy unrestricted, which is noteworthy when being run at the highest level. The no logo command at the start suppresses the logo of PowerShell. When it starts dynamic compilation, this allows attackers to generate and execute code on the fly, which can lead to various malicious actions such as data exfiltration, system compromise, or lateral network movement. The second Sigma rule detected of dynamic.NET compilation via C# compiler exe. Any execution of the C# compiler when invoked from unusual or suspicious contexts, like PowerShell, is important to note, as it may be used by malware to evade detection, as it allows the payload to be generated and executed in memory without leaving significant traces on disk. The third rule of a dynamic C# compile artifact shows that when the process of compiling the C# code at runtime, a compile artifact was left behind. A non-interactive PowerShell process spawns when the user is unable to interact with PowerShell and execute codes by itself. Any PowerShell scripts that are run on their own are noteworthy and should be further analyzed, and we will see cases of this later in the report. This Sigma rule, Windows processes suspicious parent directory, refers to a situation where a legitimate process, like command line, PowerShell, or other system processes, are executed from an unusual or unexpected location. Common suspicious directories might include any temp files, the users directory, or the System32 directory. Legitimate .NET applications typically reside in expected locations, like the C drive program files. So when we can see them being under user directories and temp directories, this raises the alarm bells for potentially harmful activity. For this detection, the .NET compiler is being used, which is often associated with software development. However, malware authors can exploit it to create or modify executable files, which allows them to run malicious code. Some malicious activity regarding .NET compilers include malware creation. A keylogger or other malware can be compiled from a script or code located in these suspicious directories. And by using the .NET compiler in unexpected ways, it can assist malware in avoiding detection by traditional security solutions. Scrolling down to the error detection, we can see Reversing Labs has flagged this sample as 34% malicious, and VirusTotal as well has flagged it as 43%. A potential reason for the lower scores from Reversing Labs and VirusTotal is that they use detections from a number of different vendors who may have not come across this sample before and thus been unable to score it. Because the MITRE ATT&CK framework provides real-world relevance in that it is based on actual attacks, it helps enhancing understanding of malware by providing a structured and detailed approach to analyzing adversary behavior, making it an invaluable source for cybersecurity professionals. Some techniques that this sample was able to match against the MITRE ATT&CK framework include defense evasion. Some of these techniques include obfuscating its code, using legitimate tools for malicious purposes, such as in this case PowerShell. And by employing these techniques, this PowerShell keylogger aims to maintain its persistence and remain undetected for as long as possible. It's been identified as showing a lot of discovery techniques as well. These techniques might include querying system information, scanning for running processes, or gathering data about network configurations. This can help the attacker and keylogger understand the environment better by identifying high-value targets on the system, thus making the keylogger more effective in capturing sensitive information. And then a final area of the attack matrix, where this sample has shown strong techniques, includes privilege escalation. And some of these techniques may avoid exploiting vulnerabilities in the operating system or applications, and using credential dumping to access high privileged accounts. With elevated privileges, this PowerShell keylogger can access more secure areas of our system while increasing its chances of capturing valuable information. For the antivirus, machine learning, and generic malware detection, Reversing Labs has labeled this sample as a Win32 Trojan generic. To break this label down, the generic classification suggests that the detection does not correspond to a specific known variant of a Trojan, but rather to a broader category. This means the sample may exhibit behaviors commonly associated with a number of various types of Trojans. The Trojan behavior, these are malicious programs that are designed to deceive users into installing them, and they can perform various harmful activities, which may include downloading additional malware, which we found was evident in this sample, stealing sensitive information, and providing remote access to attackers. And the Windows 32 section indicates that the Trojan is designed to operate on Windows operating systems, which are the most common targets for malware due to their widespread use. The world map of contacted IPs show that the 2 IP addresses which were reached out to were located in the United States of America and in Italy. There were no malicious detections for these 2 IP addresses in the IOC report, which I'll show in a brief moment. And the reason for this may be because the Microsoft servers that the PowerShell keylogger was reaching out to were located in these 2 countries. When looking at the created or dropped files from the sample, we see that there is one file which has been flagged as malicious. A breakdown of this file shows that we're dealing with a command that compiles a C# file into a DLL. This specific command references the System Management Automation assembly, which is used for creating scripts and command line utilities in PowerShell. With JoeSandbox strongly believing that this DLL is part of the keylogger, it can be designed to capture keystrokes and potentially log them for malicious purposes. Looking at the IRC report for this sample, we can see that there are a total of 13 files which are either created or modified from the keylogger. 2 files have been classed as malicious, and these are the original Trojan. And also this file here, which is stored in the local temp directory with the command line extension. We can also see here that the 2 IP addresses contacted haven't been flagged as malicious, and these are the ones from Italy and the United States. The 3rd IP address is the local host virtual machine. Some information on how the sample performs evasive actions on JoeSecurity's dynamic analysis is that there is a thread sleep time for the PowerShell executable, which we can see is set here. There's also an additional thread sleep time on the service host executable, listed as 30,000 seconds. And after dropping the malicious DLL file in the local temp directory, we can see that the keylogger attempts to disable application error messages for PowerShell with the process information set to no open file error box, which shows that when the PowerShell script is attempting to execute, it doesn't want any errors to show on the virtual machine. Thank you for watching this dynamic analysis on a PowerShell keylogger with JoeSandbox Cloud Basic. Some of the key characteristics covered in this video is that it utilizes PowerShell scripts to run and capture keystrokes on the virtual machine, and this aids in it less likely to be detected by traditional antivirus solutions. Its stealth techniques include dropping a DLL file in the user temp directory and altering the execution of PowerShell to open with no logo and to not show any error messages. This PowerShell keylogger may include remote access, as it needs to send captured data back to the attacker's server and command and control center, although the only 2 IP addresses listed in this report are not enough to make a certain assumption. Its pervasive mechanisms include modifying startup scripts and executing code on the fly, and its targeted environment of Windows and PowerShell show that its aim is to target as many devices as possible. Thank you for listening.